Yeah. Hello students, hope everyone is fine. Now we are going to start the next introduction part, which is conditions for unique, infinite and no solution. In the last class introduction part, in the first video, we discussed about if I have pair of linear equations, there are three possibilities. One, lines can be parallel. So this is the case where the lines are parallel, the first one. Then the lines can intersect at one point. This is the condition 2. And condition 3 is lines coincide each other. Okay, so this condition we discussed for no solution. Here I written no solution. Where they are intersecting at one point, they have unique solution. When they are coincide, there will be infinite many number of solutions. And we also discussed the what are the conditions for no solution. For no solution, a1 upon a2 is equals to b1 upon b2 is not equals to c1 upon c2. So no solution or parallel conditions, so the condition is same. Now when we have unique solution, then I have a1 upon a2 is not equals to b1 upon b2. Okay, so this ratio will never be equal. Then I have a unique solution. That means lines intersect at one point. Now when I have a1 upon a2 equals to b1 upon b2 equals to c1 upon c2, all the three ratios are equal. Then we say them the coincide lines and there will be infinite many solutions. This all parts we already discussed in the last video. Just we are recapping the topic. Now just take the example to understand what do you mean by no solution, what do you mean by unique solution, what do you mean by infinite solution. In the last class we also discussed on the pair of given equations how to get the value of a1, a2, b1, b2, c1, c2 and all. So here I have the equation. First equation is 2x minus 3y minus 4 equals to 0. And the second equation is 4x minus 6y plus 3 equals to 0. So here a1 value is 2, a2 value is 4. So I got 2 upon 4 here. Then b1 value is minus 3, b2 value is minus 6, which is not equals to minus 4 upon 3. This is the values of C1 and C2. Minus 4 is C1 plus 3 is C2. Now if you observe the first two ratios, 2 upon 4 is 1 by 2, minus 3 upon minus 6, minus minus will get cancelled, and 3 1s are 3, 3 2s are 6. So minus 3 by minus 6 also will give me 1 by 2. That means first two ratios are equal. But do you think minus 4 by 3 will give me, after simplification, it will give me 1 by 2? No, right? So that's why here a1 upon a2 is equals to b1 upon b2, but not equals to c1 upon c2. So if this condition is satisfying, then I have to say the lines are parallel and no solutions. Okay. Now take the another example. Here I have the first equation as 3x minus 3x plus y plus 2 equals to 0. And another equation is 4x plus 5y minus 3 equals to 0. So here if I write a1 upon a2 and b1 upon b2 values, a1 is minus 3, a2 is 4. So I'll get minus 3 upon 4 here. Then b1 upon b2 is 1 upon 5. Do you think minus 3 by 4 is equals to 1 by 5? Obviously they are not equal. So hence a1 upon a2 is not equals to b1 upon b2. This is the condition. a1 upon a2 is not equals to b1 upon b2, which means unique solution. So here, if you observe the first example or second example, actually I am not solving the equations. I don't know what are the x values or what are the y values. But just by looking at their coefficient and comparing the ratios, I can decide whether the equations can be solved. If it is solvable, how many solutions are exist, unique solution or infinite solutions. Understood? So without knowing the values of x and y, still we can uh, estimate the answers, whether you can find the answers or not. Third case I have taken here, x plus y, x plus 3y equals to minus 5 equals to 0, sorry. And the second equation is minus 3x minus 9y plus 15 equals to 0. Now here if I find the ratios, a1 upon a2, a1 is 1, a2 is minus 3, so 1 upon minus 3 equals to b1 is 3, b2 is 9, so minus 9, so 3 upon minus 9, which is equals to c1 is minus 5 and c2 is plus 15. Now you see, if I simplify all these ratios, all the three ratios, I think everything will give me minus 1 by 3 only. Here 3 will get cancelled in 9 3 times, 5 get cancelled in 15 3 times. So everything will give me the answer as minus 1 by 3. So all the three ratios are equal? Yes. A1 upon A2 is equals to B1 upon B2 is equals to C1 upon C2. So hence all the three ratios are equal. That means they are coincide lines, infinite solutions exist. Okay. Now here I use the few more. I hope you understand this example. If no solution means how to, no solution or unique solution or infinite solution. I have to find A1 upon A2, B1 upon B2 and C1 upon C2. If all these three ratios are equal, then I'll go for infinite solutions. If A1 upon A2 is not equals to B1 upon B2, then it will be unique solution. And third one is A1 upon A2 is equals to B1 upon B2, but this ratio is not equals to C1 upon C2. Then I can say they are parallel lines and no solution. When you come to unique solution, here I have A1 upon A2 is not equals to B1 upon B2. Now I am not having any relation with C1 upon C2. Okay. Whether it is equals to C1 upon C2, whether it is not equals to C1 upon C2, it doesn't matter. Only thing is A1 upon A2 must not be equals to B1 upon D2. That is the condition for unique solution. We don't bother about the constant C1 upon C2. But other two ratios, where for no solution and for infinite solution, I have to find all the three ratios. Whether all the three ratios are equal, then infinite solution. Then third ratio is not equals to the ratio of first two terms, then no solution. That is the parallel condition. Hope these three conditions are clear to you. There will be 1 mark or 2 mark questions based on this concept in the board exam or in a class test, unit test, whatever you take. If this chapter involves, there might be a 1 mark question or 2 mark question based on this concept. Now here I have written the inconsistent, then consistent, and again consistent. So if the solution exists, if I have the pair of linear equations in two variables, if the solution exists in the sense it may be unique solution or it may be infinite solution. If solutions are possible, maybe one solution, more than one solution. In both the cases, I can say the system of equations are consistent. Okay. So consistent I can say if the solutions exist, it may be unique or infinite. And if no solution, that means you cannot solve the equations. I think last video 1 we have given one example that solutions are not possible, if you remember. I explained that also. Okay. If no solutions are possible, then I say the system of given pair of linear equations is inconsistent. They are inconsistent. If these solutions exist, whether it is unique or infinite, then they are consistent in both the cases, whether it is unique solution or it is infinite solutions. Okay. Now I give the homework here. You have 4 questions here. Find which of the following pair of linear equations has unique solution, infinite solutions, or no solution without solving them. Without solving them means without actually finding the value of x and y, you have to decide. How will I decide? Using this concept. By comparing the ratios of A1, A2, B1, B2 and C1, C2, I can decide whether it has a unique solution, infinite solution, or no solution. Okay, no need to find actual x and y values, just to find the ratios and decide. Okay, this is the homework. Now, as I said, there will be 1 mark or 2 mark questions. Now we are going to solve those questions of 1 mark or 2 mark. Finding the value of k by using the given conditions. Okay, instead of a1, b1, or maybe in place of a1, a2, or b1, b2, or c1, c2, or any one of them out of 6 variables, constants, one of the constant or two of the constants or three of the constants, the terms involved k will be given and some conditions will be given to you. You have to find the value of k. Let's see what it means actually. So here I have taken the example. Find the value of k. Will the following pair of linear equations have infinitely many solutions? I think this is find the value of k for which the following pair of linear equations has infinite many solutions. So equations I have taken here directly instead of maybe if you want you can paste here one. Let me keep the equations here only. They are changing the position. So first equation is given to is kx plus 3y minus of k minus 3 equals to 0. And the second equation is given is 12x plus ky minus k equals to 0. Now first let me write what is a1 value. A1 is the coefficient of x, that is k. B1 is the coefficient of y, that is 3. C1 is the constant term. Now here which one I have to take the constant? Should I take k value is the constant, k is the constant, or 3 is the constant? Actually this entire thing will be the constant term. Constant term is the term which does not involve any x or y variable. Okay, so if I consider minus of k minus 3, it has no x term, it has no y term. So the whole thing will be C1 value. So what I do is minus of k minus 1. This is what exactly the way of considering A1, B1, C1 value. Now if I come to the second equation, A2 value is 12, B2 value is k, and C2 value is minus k. Got it? Now the question arises, I got A1, B1, C1 value, A2, B2 and C2 values. All the 6 values I got is, what is the given condition? I said finding the value of k using given condition. That is what our topic is. Here the given condition is, the given system of equations has infinite many solutions. Can anyone tell me what is the condition for infinite many solutions? Yes. Just now we discussed for condition for infinite many solutions is A1 upon A2 is equals to B1 upon B2 is equals to, I'll give the condition here. A1 upon A2 is equals to B1 upon B2 is equals to C1 upon C2. So let me substitute the values. A1 is k, then A2 value is 12, be careful. B1 value is 3, you have to substitute correctly. B2 value is k, then C1 value is minus of k minus 1. If I open the bracket, can I write this is minus k plus 1, because minus into k is minus k, then minus into minus 1, minus of minus will be plus 1. And what is C2 value? Minus k. This also you can solve, no problem. Now you have a doubt, sir. There are 3 ratios here. Which ratio I have to consider to find the value of k? It is up to you. You take first 2 ratio, k upon 12 equals to 3 upon k, or you take the another ratio, 3 upon k equals to minus k plus 1 upon minus k, or you can take k upon 12 equals to minus k plus 1 upon minus k. Which one is the easiest way to solve? I think by taking first and second ratios are equal, you'll get the same value. By taking any ratios are equal, you get the same value. So I think by taking the first two terms, so what do you get? If I do the cross multiplication, this k multiply with this k into k is k square. So let me insert the equation for k square. K into k is k square will be equals to, can you tell me what is 312? 312 is 36. So you got k square equals to 36. If you already studied, then what could be the value of k? K equals to, I think, let me insert the again equation. Yes, plus or minus 6. Now you might have the doubt, some of you, what is plus or minus 6? If I take plus 6 whole square, that also will give me answer as 36. Even if I consider minus 6 whole square, minus 6 whole square means minus 6 into minus 6, that is 36. So both plus 6 and minus 6, the square of both the terms will give me answer as 36 only. That's why k value will be plus or minus 6. So whether you take plus 6 or whether you take minus 6, this system of equations will give you infinite many solutions. Okay? You take whether plus 6 value or minus 6 value, both the system of equations will give you infinite solutions only. Okay, so this is one example. Using the given conditions, you have to find the value of k. So I solved that example for infinite many solutions. Let's move to the another example. Let me bring to the top. Yes. What is the example 2 says? If the equations 2x minus 3ky plus 3 equals to 0, this is one equation. 3kx minus 2y plus 7 equals to 0 has unique solution, then find the value of k. So condition for unique solution is a1 upon a2 is not equals to b1 upon b2. So if it is 2 mark question, 3 mark questions, you have to write this step also. Condition for unique solution is a1 upon a2 is not equals to b1 upon b2. If it is 1 mark question, no need to write. So a1 value is from the equations, if I consider a1 value is 2, a2 value is 3k, then b1 value is minus 3k, and b2 value is, yeah, and b2 value is I think minus 2. Okay, so if I solve it and simplify it, what do you get? 2 into 2 is minus 4, is not equals to 3k into minus 3k. It will be minus 3 into 3 is 9, k into k is k square. So let me copy this k square term from here to here. Okay, just forgot. Yeah, so I got minus 4 is not equals to minus 9k square. So minus minus will get cancelled. Then you'll get 4 upon 9 is not equals to, oh sorry, k square is coming. So control D, here again I have to type, sorry, this mathematical steps as I explained, control V. So 4 upon 9 is not equals to k square. Then as I said, so if I bring a square this side as square root, then you'll get it as plus or minus square root of 4 is 2 and square root of 9 is 3, which is again not equals to control C, control V. Okay, so I hope this way of solving is understood. What I have done is 2 into minus 2 is minus 4, 3k into 3k is 9k square and minus sign will come. Now I bring this 9 to the left hand side. So it will multiplication will come as a denominator. Minus minus is getting cancelled. 4 upon 9 is not equals to k square. If I do square root on both sides, plus or minus 2 by 3 is not equals to k square. Sorry, it's not k square. Because already I removed the square. K is not equals to plus or minus 2, 3. That means your k value cannot be equals to 2 by 3 or minus 2 by 3. Then only this system of equations has unique solution. Okay. What it means is, if I take k equals to 2 by 3 or k equals to minus 2 by 3 and I substitute here k value as 2 by 3 or minus 2 by 3, then you will not get a unique solution. It may go for no solution or it may go for infinite solution. But if I take k value other than 2 by 3 and other than minus 2 by 3, any other value except 2 by 3 and minus 2 by 3, you take 1, minus 1, 0, 2000, 10 lakh, anything. This system will give you always unique solution except these two values, plus 2 by 3 and minus 2 by 3. So we solve for infinite solution, we solve for unique solution. Now we will solve for no solution. So what is the example here? For which value of k will the following pair of linear equations have no solution? So what are the equations are given? 3x plus y equals to 1. 2k minus 1 into x. So this entire thing 2k minus 1 is in the bracket. So this entire thing is the coefficient of x only. Plus k minus 1 into y equals to 2k plus 1. Now if I compare condition for no solution, right? Here condition is given as no solution. So no solution condition is parallel lines. So condition is a1 upon a2 equals to b1 upon b2 is not equals to c1 upon c2. Yeah. So if it is the condition, now let me get a1 value. A1 comes from the first equation, that is 3 upon a2 is from the second equation, 2k minus 1. Then b1 is y. So y coefficient is 1. So here b1 value is 1. Then b2 value is from the second equation y coefficient, k minus 1. So here it is the k minus 1, which is not equals to c1 is the constant from the first equation, c1, and c2 is the constant from second equation, that is 2k plus 1. Here I kept 2k plus 1. Now here you might have the doubt. In the video 1 first class, we discussed c1 and c2 always it has to be on the left side of the equality, and after equality it has to be 0. Okay. So if I bring 1 this side, it will become minus 1. And if I bring 2k plus 1 this side, it will become minus of 2k plus 1. So both terms are negative. C1 is also minus 1. C2 is also minus of 2k plus 1. When I write C1 upon C2, so both the minus signs will get cancelled. C1 is negative value and C2 is also negative. Both the negative signs will get cancelled. So that's why I have written here both the positive signs. The problem comes if C1 is on the left side of the equality and C2 is on the right side of the equality, and without transferring them into the general form if you solve, then the problem might arise. If both are on the left or both are on the right, then there is no issue. Okay, so there will be no problem. Now here two cases will come when I want to find the value. So students get the doubt whether I have to consider this case or whether I have to consider this case. Which one I have to consider? So here I solve for both the cases. Case 1 I solve for this. 3 upon 2k minus 1 equals to 1 upon k minus 1. When I solve it, so 3 will be multiplied with k minus 1. So 3 into k minus 1 here will be equals to, here 1 will be multiplied with 2k minus 1, right? So 1 into 2k minus 1. So when I open 3 into k is 3k, 3 into minus 1 is minus 3. So here I got 3k minus 3 equals to, here we are multiplying this term with 1. So multiplying with 1 doesn't make any difference. So that's why 2k minus 1 I kept here. Bring this If you want one step, you can write here. What you can write here, it is, some might have the doubt, 3k minus 2k if b equals to minus 1 plus 3. Why I written minus 1 plus 3? Here what I am doing is, this 2k is on the right side, so I am bringing 2k to the left side. So plus 2k will become minus 2k. If 2k is coming this side, here minus 1 will be left out. So thus minus 1 will be as it is. And here minus 3 is on the left side. So I am bringing to the right side. So minus 3 will become plus 3. So 3k minus 2k is k. And minus 1 plus 3. Minus 1 plus 3 or 3 minus 1, which is 2. So by solving this, I got the value of k is 2. Now go to the case 2. Oh, sorry. Case 2 I am solving with this one. If these two ratios are not equal, 1 upon k minus 1 is not equal to 1 upon 2k plus 1. Here also the cross multiplication will take place. This 1 multiply with 2k plus 1. So 1 into 2k plus 1 is 2k plus 1. Then here this one will multiply with this k minus 1. So 1 into k minus 1 is k minus 1. If I simplify this term, k will come to the left hand side, plus 1 will go that side as minus 1. So 2k minus k is k, minus 1 is minus 2. So here I have either k equals to 2, then I might have no solution. And here I have k is not equals to minus 2. K is not equals to minus 2 means k cannot be equals to minus 2. K should not be minus 2. You cannot take k value as minus 2. Then you will have infinite solution. Oh, sorry, no solution. This is for no solution, right? So then you will have no solution. If k is not equals to minus 2, are you getting? K is not equals to minus 2 means k can be any other value. K can be 1, k can be 2. As I said, k can be 1 or k can be 2. Already I got k can be 2 here. So this condition doesn't make any sense, because once I get k is not equals to minus 2, k should not be equals to minus 2 means k can be any other value. It can, out of infinite values, it cannot be minus 2, but it can be another other value. So then I'll have no solution. Okay. So now you can check at home what happens if k equals to minus 2. Okay. If k equals to minus 2, then you check, I think it may have unique solution or it may have infinite many solutions. One of those conditions may come. So now we solve all the three examples based on what are the infinite solutions, how to solve the example. If the condition is given as infinite solutions, then we solve the second example with unique solution, how to find the value of k. Then the third example we are solved how to find the value of k if no solution is given. So all the three questions, one example I explained. Now here I have three more homework questions. Previously I have given 4 questions. Now 3 more questions as a homework. One is for unique solution, one is for infinite solutions, and another one is for no solution. So here I use unique solutions or consistent. Say in the question here I use the word no solution, but they might use, instead of no solution, they might use inconsistent. So then also the process remains same. The way of solving the question will remain same. And here also unique solution or infinite many solutions, they can use consistent word. In the question, if they use consistent word, so you can solve that question by infinite many solutions or no solution. You can use any of the method to find out, because both will reflect me consistent only, so you can use any one of them. Okay, if it is MCQ question and you solve for unique method and the answer is not there, that means the answer might be available by using infinite many solutions. So that care has to be taken in the exam. Okay, because A, B, C, D options are there. You solve with the unique solution method, but options has no unique solution option. That means they solve that example with infinite many solutions. Then you have to try with infinite many solutions. Definitely your answers will be there. until unless you don't do any mistake. Okay. So this is another topic which we discussed. Uh, Conditions for unique, infinite, and no solution. What are the conditions we have? Then how to finding the value of k by using these conditions. Now you might get the confusion when you open the textbook. Your first exercise based on the graphical questions, second, third, fourth exercise based on the three different methods how to solve them. Your fourth exercise have few questions based on the topic which we discussed. Okay. So if you want to start NCERT questions, you can start with the fourth exercise. Otherwise, you wait for some time. I'll give the time to complete it. Okay. So thank you. Have a nice day. Keep understanding. Most of the students are not asking the doubts. If you have any doubts, you may ask. You can send me the WhatsApp on my WhatsApp number. Thank you. Have a nice day. Be safe.